Hello everyone. In today's video, I will show you how you can implement ORM in your Haskell project. The concept of ORM is not new in backend frameworks. Almost all backend frameworks support some sort of an ORM library, such as in Python we have SQL Alchemy. Just like that, in Haskell we have B. There are also some other ORM libraries exist in Haskell, such as Persistent, Zelda, Haskell, Raylate, all these. So for this video, I have picked Beam, but once you get the gist of it, you can use any other library as well. The benefits of ORM is really, the biggest one is making your SQL queries type safe and reusability of the queries. So if you are not using any ORM library, and if you are writing raw queries in your Haskell code, then though there is no guarantee that the queries are correct or not, it doesn't get type checked. So in order to make the queries type checked, ORM is a must. Also, let's say that in your database you may change some columns type, or maybe you change your column name. You have no way of finding it out unless and until the runtime. So to check that stuff at the compile time, ORM is a very important thing. So without any further ado, let's start. So this is the documentation for the Beam library. I think everyone should give it a read. This is I have started the project, a stack project here, and what I will do in source, first I will create a database with few tables on which we will first write some normal SQL queries, and then we will convert those SQL queries into the Beam related queries. So let me just have a file called schema, and okay, so these are the tables. I have already added these tables in my database, so I'll just explain them. So we first have a customer table that contains like customer ID, first name, last name, email, created at. The created at is a timestamp, and you can see that whatever the columns that I want to say that they are not null, I have explicitly mentioned them, and the fields which are optional I have not mentioned, those are nullable fields. So then next we have category. It says category ID and name. Actually forgot to put not null here. Then we have product name, and then the category ID is the foreign key for the category table. Then we have orders. So order contains the foreign key for both the customer ID. It just contains the customer ID's foreign key. Then order item will contain the order, and the order ID has a one-to-many relation. So you can see that order item has the foreign key of order ID, as well as it has the foreign key of the product ID. So I mentioned the product here as well. And these are just some raw data, some sample data that I have added here. So let's discuss the SQL queries as well that I want to implement. So let me okay, so yeah, these are pretty simple queries, I would say. So stuff like custom, first of all we'll start with a very simple query like fetching stuff from a table, then fetching some certain columns from a table, then we'll use the where condition, then order by is something that is important for one to know, then group by clause, then subqueries, then joins. and all that. So we will use all these queries. So let's go into our project, and what I'm going to do is I'm going to have two files. First I'll have a folder. I'm going to call it example. Inside that folder I want to have two modules. One is going to be model.hs. Okay. The other one is going to be where we will be writing our query function. So I'm going to call it query.hs. Okay. So we have our database ready. We have all these tables. Now we want to write its equivalent Haskell types, and not just Haskell types, but the types which would be understood by the Beam library. So we will start writing them here in our model. So let me just start the GHC ID. This is just a warning, it's not a big deal. So first let me go to package and let me remove this warning. It is saying that the export list is missing. We don't need to have that sort of warning. And in the dependencies I want to add a few. So the first one is going to be the Beam core, and I will be using Postgres database. So for that I will need Beam Postgres as well. And in order to create connections and everything with the database, I'll probably need Postgres simple, though I doubt that I'll need it, because Beam Postgres sort of re-exports some of the required modules from Postgres simple as well. But I want to use like with connection with transactions. For that reason I'll use Postgres simple. And then I'll just have text and byte string. Maybe I'm not sure whether I'll need it or not, but let's just have it. Then so it is giving me, looks like it is giving me some error regarding the Beam package. So if I did this, it is telling me that the Beam Postgres it is required for Beam core, but I guess it is not part of the stackage. So it is telling us to add it in the extra dependencies in our stack YAML. So let's do that. Let's go to stack YAML, and it is saying this to add this line in the extra dependencies. So where is extra dependency? So I'll just add it here. Let's see if this works. Okay, now it is saying that these libraries are also required. So I guess these two are required because of the Postgres simple. What I'll do is I'll just okay, let's just add them in extra dependencies as well. Okay, so it's like, it looks like a major issue. I'll just give me a second. Okay, so there are two changes that I made. I first went back to the LTS version 25 and I selected this option, allow newer to be true, so that it will install all the latest packages. So now the stack is running. Just give me a second. Okay, all good. Let me go to the model, and now here we will really start our code. The very first thing that I want to do is import the beam library, database.beam, and now I want to start writing the uh, table equivalent types of our SQL tables. So if we go here, we'll start with customer. Let me just copy this and go here. Cool. So I want to write the beam equivalent table. So I will start by saying customer tf customer. Now this is really from the official documentation to have the whatever your type is with its transformer variant, and then the actual table name, because we will write a type synonym for it, which would be customer. So also it's a best practice to have your field names starting with underscore. So I will do the same. Customer ID, it would be its type is going to be columnar f, and the actual type. Now I will use int 32 because otherwise it will throw an error, because again, when you are using int, the int can the size of the int can vary upon whatever the machine you are using, 32-bit or 64-bit. Okay, all good. Let's add other fields. First name, it's going to be text. Last name, now last name is going to be a maybe text, because as I mentioned, the last name can be a null value. So that's why I've used maybe text, so that if there is a null, we will just have nothing. Now remember that as per the Postgres simple documentation, the Haskell equivalent type for timestamp is going to be the UTC time. So, but UTC time is sort of marshalable to timestamp TZ and not timestamp. So make sure that that is correct. So I'll import data.text, and I will also import data.time, and I'll just import its definition. Now time does not exist, we also need to add time in our package. Let me restart. Okay, all good. Now let's say deriving, it will be, now every type needs to have a generic instance, and then so that we can have the beamable instance for our table. Now in order to have it, make it generic, I guess we need to import okay, I don't think we need to import anything, but we will probably need the extension language derive generic. Yeah, and we also need to have another extension enabled, that is derive any class. Okay, great. So we have written the type for it. Now we need to write two things. Obviously we will need to define the primary key for it, which would be the customer ID, and we also need to have the identity type. So this is the transformer variant. We also need to have the non-transformer variant. For that we will basically just say that the non-transformer variant, the normal customer, is nothing but the customer T identity. So we can do that by saying customer, the type customer is nothing but customer T identity. Okay, and we will need customer ID, which is going to be nothing but the primary key of customer T identity. Okay, great. Now we should give these two types the show and EQ instances. So I'm going to say deriving instance show customer, and also EQ, and EQ here, this is going to be ID, this is going to be ID. So in order to do this, we need to enable the extension called standalone deriving. So let's do that. Alone deriving. I guess we also need a couple of other things as well. We will have, I guess, flexible instances will remove this error. Standalone. How about type families? So for some reason these two are not the instance for ID is not working. We'll take a look at it later. So we have written the instances for the table. Now we also need to have a instance, the table instance for whatever the table we have, that is customer T, to define the primary key for it. So the primary key is going to be primary key customer T F, then it will be nothing but customer ID, and now the type of whatever our customer ID is, that is this columnar F32 int 32. And this type will also need to have a generic and beamable instance. No explicit primary key, let's do that. And the primary key, here we are going to mention the primary key, which is going to be customer ID with the actual type, that is customer ID. And now I think we can actually write the instances for customer ID and show any key instance for customer ID, now that we have defined them as exactly what is customer ID. So that's great, and I think that's all that we need to define the table for customer. One last thing, we also need to define the database. So let's define a type for the database as well. So I'm going to say data, let's just call it DB, DB, and here basically in the database type, the fields are nothing but going to be the tables. So I will have the customer table, whose type is going to be table entity. And I can have this as a table entity type because it has the table instance, remember that. So customer T, and deriving again generic and beamable, and not beamable actually, there needs to have a type instance called database DE. Yes. And now in order to access the database, we need a function, we'll call it database, which will give us the database info, database settings, PE, and the type, that is DB. So let's it will contain all the default DB settings, and I want to modify. Now what I want to do is I want to tell here, I will decide exactly that okay, I have a table called customer who it is getting mapped to in the actual database. For example, customer ID, as I mentioned in our schema, there is customer underscore ID, there is first underscore name. So I want to, I mean, I don't sound like being paranoid, but I want every table to have an explicit string, explicit way of defining that this customer ID is nothing but the customer ID from customer table. So we need to define that in here. I will say db modification, and here inside this I will mention all the table names and their field names with their equivalent database names. So for customer, I want to set its table name as well. So I'm going to say set entity name customer. I assume it is customer and not customers. Okay, customer, and I'm going to set the names now. So it would be modify table fields, table modification, and it would be category ID, sorry, customer ID, and its equivalent type is going to be customer underscore ID. Same for first name, last name, and all those things. So I will quickly write them. So it is giving me a lot of errors. So I guess the biggest error is that it is not able to understand that this string is the text type and not the string type. So for that I'll need the overloaded strings extension. Okay, perfect. Yeah, and I think that's pretty much it. So now that we have enough information about the customers table, we can actually write the query function to fetch all the info from the customer table. So let's actually write the query. So what I'll do is in our, I guess, query function, yes, I'm going to say module example.query, where I'll have a function called fetch customers. This will return a list of customer type. Okay, no errors, that's odd. I'm going to say import database B import I will need forgot the example dot model. Okay, beam is redundant. Okay, all good. So how to write the query? So I will also need to create the connection. So in order to create a connection, I will hard code the connection. So I will write all the connection details here. So for that, not sure, I think here there must be default, yes, default connection info is here. So I'm going to use this. Okay. So here I will mention all my database credentials. So which are so connect host, it is going to be nothing but local host. Then username is Tushar. Okay, and this belongs to the get connection function. Not in scope, connect host. Let me see, this is part of database beam Postgres. This okay, cool. So we will need this function. So I'm going to say with connect. I'm not sure with connect exists or not. Let's see. Yeah, with connect does not exist. So I'll probably need Postgres simple to use with connect. Okay, I'll use with connect and I'm going to call get connection. This will give me the connection info. This will create the connection, and now I can use this connection to sort of run my query. So run beam Postgres connection, and now since I want to return a list, I'm going to use a function called, I guess, run select returning list. Select, and I'm going to just mention I want all from underscore customer. This is the table name from DB, and it works, no problem. Let me just give the type signature, which is connect info. Okay, all good. Let's try running this. Oops. I'm going to say stack REPL import example query and fetch customers. So you can see it is giving me a list with customer ID 1 and customer ID 2. There are two customers in my database. So yeah, that's yeah, we successfully write a single query using our what you can say table that we just defined in our model. So what I'll do is I will just quickly write other table as well, but I do want to show you how to write and manage the foreign key tables as well. So I'll write till I write tables till I come across uh, one table with foreign key, and then we'll move on. Then we can just skip that later part. So now I will write category. So category TF, category, it will have category ID, which would be again similar to customer ID, int 32. Then category name, deriving again similar to above table, generic and beamable. We'll write two more types for category and category ID. Category T, this would be category T as well. Spelling mistake, category. Okay, then we'll have to write these instances, but before that I will write the table instance. So table instance for, I guess we should have instances before the whole deriving instances show any key. Category T, where data primary key, category TF, category ID. I would say category ID, and we'll write types, deriving instances. So here it would be all good. Again we'll add the entry here, category, which would be category T, category, its equivalent table name, I assume it is category. Category ID is nothing but category ID. Category name would be category name. What is the error? Line number 63. I guess I forgot the comma. Set entity variable, not scope. It should be set entity name. Okay, all good. We wrote category. Now let's write product. Now product is kind of a table that does have a foreign key, so that is going to be interesting. So let's see. We have product ID, name, category ID, and price. Price is also something interesting. Its type is decimal. By decimal I meant its type is numeric. So if there are numeric types in your database, its equivalent sort of marshalling is not unfortunately a double. It is going to be scientific. So I'll explain. So if I go in Postgres simple, and let's say to field, no, let's try going into from field. Yeah, basically you can read this stuff and you will realize that it is basically saying that instead of using double you should use scientific. Where did it go? Let's say numeric. Yes, you can see that numeric, into, int float, these should have scientific type. So we will need this scientific library in our project. Let's just add it while we are at it. Yeah. Product key, very similar to category and customer. Now you can see this is category ID. Okay, now I can write category ID here, but my program will sort of not allow me to do it. Two reasons, and it is actually a good thing that it is not allowing me to have it as category ID, because when you start writing queries it will be very hard to distinguish whether this category ID is it part of the category table or category type or some other type or product type. So what I should do, or it is mentioned in the documentation as well, so you should say category ID for which type you are actually referring. So that is nothing but the product. So category ID for product, so that by looking at the type itself I will know that this category ID is actually part of the product type. So also it's not going to be columnar int 32. I mean, it can be, but then there will be no reference of the actual category table. So how to have that reference? We, instead of mentioning this as int 32, we will mention this as the primary key of the table name, that is nothing but category. Now you cannot mention category here, this will give us an error, because basically the category type does not exist. It should be category TF. Okay, and finally price. So for price the type should be, as I mentioned, it should be scientific, because our database equivalent type is numeric. Scientific we need to import. We have added the package. I think I need to restart it. Okay, great. Now all the remaining types for the all the remaining types I will just add them quickly. Alright, so I have written all the tables, and I have added them in the database, you can see. So now that we can actually get to the good stuff, that is writing the queries. So let's write the queries one by one. So we wrote the first query, that is this one. Let me just add this query. So we'll have queries and we'll have query, that's two. So we did this. Now let's move on to do other ones. So let's see what is the second one. So again, in this query we just will be doing the same thing, but instead of returning everything, we just want to return two things, that is first name and email. So let's just copy everything from this line. Oops. Okay, all good. Instead of it being customer type, it will be just a tuple of text and text, that is the first name and the email. Then what I'll do is I will extract the customer, so it's like the single entity, and from this entity I want to return two things, which are the first name of C and the email of C. The names I should change it. Fetch customer, I would say first name. It is saying that text does not exist, so let's import text. Let me hit import example query and fetch customer first name. You can see I got John and Jane, which were the two customers. Okay, so let's move on to the next query. That is, now we get to see the good stuff, that is the guard function, which is equivalent of SQL's where. So in this query, it's nothing but we are just fetching all the info from the customers table, just like here, and but here we will fetch that one customer or those customers whose last name is Doe. So I'm going to copy this query, paste it here. Customers with last name. Okay, and again we'll take it out. See, this should be in a do notation. Now I will use a function called guard. Now this guard will take basically whatever we have here, that is C, and it will any of the type of this customer type, that is, let's say I want to check for the last name. So the last name of C should be equal to, now remember that the beam provides us almost so last name should be equal to Doe, and we need to wrap this string inside val to convert it into basically the beam friendly type. So let me just change this. So what are we returning? We are returning the list only. Okay, so I'm going to set POC. It's I guess we don't need lambda here. Yes, so the thing is, last name, as I mentioned, is a maybe type, so it is also looking for a maybe type. So what I'll do is I'll just wrap this inside a just. Okay, just underscore. I think this will be more correct. Well, can't match type text with string. I guess we'll need to do overloaded strings. Okay, perfect. Let's try running. Fetch customers with last name. Okay, perfect. Okay, let's move on to the next query, that is now let's use order by. So we will be fetching stuff from product. So wait. Product, we will be returning a list, and we will be doing a select, that is for sure. Now instead of customer it should be product, and we don't need any guard or anything, and we can just simply return this. Okay, but now we want to make sure that it has a order. So how to do that? We can simply use the function order underscore, not under order by underscore, and you can set up, you can mention it whether we want it descending or ascending, and on the basis of what. So I want it on the basis of pricing, and this will take our table. Yeah, it will work. Let's see what else we have. Now we also, with order, we also need to have a limit operator. So let's try to see how the limit operator will look. So what we can do is, this order by is going to take this table expression, so we can add limit next to it. I'm going to say limit and the number, and I assume this will work. Yes, it got type check, means that it is correct. So the next thing is a very important thing, that is group by. So let's try to implement group by. This query basically it will give me the customer ID and the count of order IDs by that particular customer. So it's just a single table thing. I'm going to call it fetch order count, and this will return basically the what it will return. It will return me a tuple of the customer ID and the count. So the count would be int 32. Now how to do this? So for this we will need a thing called aggregate, a function called aggregate. So let's try with the aggregate function. It will take, first I will get all the orders on the order table. Then I will, this will be the lambda function that will take the single order, basically the order list, and we'll use group function inside here, that, and we'll do a group by the customer ID for order of the order, and we want count all to find the count of all the orders, and it is saying int 32 does not exist. Let's import it. With connect spelling is wrong now, looks like. Looks like I messed up with the brackets, I guess. So this is one thing, then we are grouping it in the group. Okay, understood. So this should be grouped, and okay, perfect. So yeah, this will get the count. This is equivalent of count star. So let's see what's next. Okay, this is the subquery. Let's try this. So the function, I'm going to call it fetch customers over 500. This will return me, this will just give me here now it is taking first name and last name. I'll just take the whole customer. we can, I mean, it's pretty easy to take the sub part of from the entire customer, so it's not a big deal. I'm going to say with connect get con / con run beam Postgres connection run select returning list select. Now here's what I want to do. First I will fetch all the customers using all underscore customer db. Okay, put it in the C. Then I will fetch all the orders using underscore order db. And here I will add a filter here for the order, saying that the total amount of that order should be greater than 500. So for that I will use a filter function. This will take the order and will compare where total amount of the order should be greater than 500. And we cannot use the greater than symbol, we need to use the dot. And yeah, so we have C and O. Okay, so basically C is the customer information and O is the order information. So now we basically need to join the customer and order info. So we can join it. We actually don't really have to join it, we just need to do a filter on these two tables. So we can say C and O. Basically the customer ID of C should be equal to the customer ID for order of O, and this should be wrapped inside customer ID, and all these values, the filter should get input from these guys. So fetcher, okay, I made a mistake here, it should be customers, and we are returning the customer and order, the tuple of customer and order. So let's just return that. Okay, perfect. So let's see what's next. Now we are really going to the interesting part, that is the join. So we just want to list all the information about the order, which is nothing but the customer name and the product details as well. So whenever I'm fetching a particular order, it should also give me the respective customer information and product information. For that we'll use join. More specifically, we'll use inner join. So fetch order with what to call it, customer product. And this will return the list of tuple of let's say customer, order and product. So what I'll do here is I'll first fetch the customers normally, customer DB, then I will do a join of this customer. I will say join with order DB, and now we need to mention on which we are doing the join, on which field we are doing the join. So we need to attach the orders customer ID with customers customer ID. So for that I'm going to say customer ID for order O is equal to customer ID of customer. Okay, so basically this is the join of customer and order. So you can see that we have join order and customer, and then we have also join order item, and then order item is got joined with I assume product. So we are using all 4 tables here. So I will use now the order item. It should be join underscore order item DB with it should be order ID for order item Y. It should be equal to the order ID of order ID O. Then finally we want product. We want to join product with the order item. So I'm going to say product DB /p product ID for order item. It should be OI. No, product ID for order item. Yeah, that it is part of OI, and I'm going to connect it with the product ID, that is nothing but product ID of P. And yeah, I think that's pretty much it. And now we have all these 4 things, not exactly 4 things, but we really want 3 things, that is nothing but the customer, order and product. Yes, all good. Let's try running it. It's fetch order with customer product. So yeah, you can see we have gotten the tuple of customer, order and the product and so on and so forth. It looks complicated, but yeah, this is how we got the information, and we can obviously, once we have all the information, we can check whatever we want to do. So yeah, that's all. So yeah, I mean, definitely there are a lot more things, such as the window function and recursive query, common table expression, but we will cover that in some other video. That's all. Thank you. Bye.